Have you ever wondered why a fan feels useless on a humid day, but amazing in dry heat?
The answer comes down to two key thermological properties: dry bulb temperature and wet bulb temperature. Today, we'll break these down in a way that's both scientifically accurate and easy to understand, and show why they matter in thermal design and engineering systems. Let's start with the dry bulb temperature. This is simply the air temperature you measure with a standard thermometer, shielded from moisture. It represents the sensible heat of the air, the energy you can feel directly. Engineers often denotes it as TDB. It's the temperature you see in weather apps, and it's what most people think of as temperature. But there's a problem. Dry bulb temperature alone doesn't tell us how hot it feels, or how well cooling systems will work.
Now, let's introduce the wet bulb temperature, denoted as TWB. This is measured by wrapping a thermometer in a wet cloth and allowing water to evaporate.
As water evaporates, it removes heat through latent heat transfer, cooling the thermometer. The main idea is drier air means more evaporation, resulting in a lower wet beam temperature. More humid air means less evaporation, resulting in wet beam being close to equal to dry beam. Drier air means more evaporation, resulting in a lower wet beam temperature. More humid air means less evaporation, resulting in wet beam being close to equal to dry beam. This is a direct application of thermodynamics and energy balance. The amount of heat removed is equal to the latent heat of vaporization times the mass of evaporated water. This is shown in the equation, Q equals HFG times MEVEP. So what's the difference? Dry bulb temperature tells us how hot the air is. Wet bulb temperature tells us how much cooling is possible through evaporation. The difference between dry bulb and wet bulb temperature is called the wet bulb depression, and it directly relates to humidity.
The wet bulb depression directly relates to humidity. The higher the humidity, the smaller the depression. This is critical into menidzdem, thanas the yeving volatridis, and it never polichu thriskri. This may contescal in engineering applications, especially jack systems, where it determines cooling load and comfort levels. In cooling towers, the wet bulb temperature sets the lowest possible cooling temperature. You cannot cool water below the ambient wet bulb temperature. Engineers use these properties in phytometric analysis to design efficient thermal systems. Hun states that turetrasis instoys the wet dimetric thervals.
So the next time it feels unbearably hot outside, remember, it's not just the temperature. It's how much evaporation your body can achieve. Dry bulb tells you the heat. Wet bulb tells you your ability to cool. And in thermal design, that difference is everything.